Guys, welcome to another YouTube video. In today's video, we are going to be working on the chapter 2 of the Rust book. Basically, Rust by example book. And what we are going to be doing today is we are going to be building a very simple game using Rust. And so I'll just dive right into it, but give a little bit of explanation as to how this game would work. So this game is going to be divided into, or this video is going to be divided into three sections, and these three sections are based up on the three sections of the application we are going to build. If you take a look at my screen, you see that I've already set up my work environment using Cargo New and opened it up on VS Code. I already have the source folder with the main and the hello world and all that already here. So yeah, so about the project, the first things we are going to do here is, first of all, it's a game. It's called a guessing game. And what this game does is simple. We'll take an input from the user from the terminal. And when we take this input, we would compare it with a random generated number and spit out something telling the user if they won. That is, if their number matched the number that they entered, if like the number they entered matched the random number that was generated, or if it was lesser or higher or something like that. So basically, it's just a very simple game, just to get us familiar with the ins and outs of the language itself. So without wasting much time, I'll just go ahead and start. So the first part of building this program is first off would be okay. I'll first of all sanitize my yeah, okay. So the first part of building this game is to ask for the user's input and check if if the input is there's what we expect, something like that. So to start, we would basically allow the user to input something on the terminal here. So let me say a number like 10, and take that number and do something with it. So the first step of doing this is, first off, I'll take off the hello world. So the first thing I want to do is I want to print something to the console, to inform, a way of informing the user that, or the player, that um we want them to guess a number. So we'd say print line, uh, print line. I would say please the number, please pick a number. Use three exclamation marks. When I save, yeah, save this, and yeah, or please enter a number. I think that would be better. Please enter a number. So in order for us to be able to get the user's value from the terminal, we'll be using something from the standard library called the IO. So the IO stands for input and output. So we'll be importing it into our program. So it's something that is you know is automatically included in any program that we're writing, as long as we import it, basically. So we're going to be getting the input and the output from the standard library. This will enable us to be able to get the user input from the terminal. So we'll do this by saying use std, and in that place we have the IO, which is the input and the output. So, so once we've imported this, we want to go ahead and make use of this in order for us to be able to get the user's input. So the first thing we'll do here is would say IO And in that IO, we want to get the standard input. So std in, and want to call this method. Then on that method, I want to get the read line. So this read line is going to be in charge of passing whatever input that was entered into a string which we are going to create. So basically, we are going to pass that value to our string to store it in a string, basically. So, but for now, I will just go ahead and say read line underscore line, and so this line is where all the magic is happening, at least for now. So I'll just quickly go ahead and make some corrections to some things I did. So add double column there, a semicolon at the ending, and also a semicolon here. So the next thing we want to do now is we want a way to store the value that we are going to be getting from the readline method. And the way we do this is by creating a string. So a string. So we'll say let's create say value is equals to string. Let value be equal to a string, string new dot new. So basically, whatever value we get, this read line will be passing it into our string. So in Rust, every variable is by default immutable. In order for us to make it, sorry, is immutable, yeah. So we have to explicitly make it mutable. And what that does for us is that it enables us to be able to use this value in other parts of our application. So in order to do that, we'll add the mute keyword here, and also we're going to be looking at references, mutability, and so many other things in coming videos. But for now, I'll just gloss over them. Um, I'll just gloss over them. So in the read line, would have something like this. So we want a reference, a mutable reference, and we want to pass in the value. So now what does this particular line of code do? So what this line of code here does for us is, what it does for us is that it enables us to be able to use, this value in multiple parts of our application. The reference enables us to use value in multiple parts of our application. And because we are not going to be copying data in memory, instead we are just passing the reference to this value here that we need it. I know it's quite complex to understand, but believe me, it's really easy if you think about it. So we don't want to copy the data in memory. We just want to, refer to it. So a reference to the value. That is what this ampersand here means, basically. So with that, we have successfully been able to pass in whatever value that we are receiving from the read line to our string. So for readability sake, I'm going to copy this. The next thing we'll do now is the next thing we'll do here is to look for a way to just for testing purpose, print that value to the console. So I would say print line. I would say oh, value is passing uh, passing this. Call it. Let's see if this works. So I'll go ahead and cargo um, value to run for some time. Exactly. So I get the first one. Please enter a number, and it's expecting me to enter something. So I'd say 4 or 5, and hit enter, and I'll get your entered value is 5. And so this is basically like saying a new line. So in order to prevent that, I'll just go ahead and instead of passing the formatted, I'll just pass in the value directly and move this. Uh, I should run this code again, save, and run this code again. Go run. Yep, this time around I'll go with 99, and yeah, so we have your entered value is 199. So quickly I'll just go over everything once again. So the first thing here is we you know first thing is we imported you know these input and output from the standard library, raw standard library. We declared a function, so the fn keyword, and then we know that in Rust everything starts from the main function. And after doing that, we created a prompt to improve user experience to tell the user that they need to enter a number. After that, we got the user input from the terminal, from the input output standard library, where we got the readline method, and then we're handling our errors here. And we created a string. So we created a string or a variable where we stored our values in a string in a string or in the value or sorry in the variable itself. And then here we have the variable which is mutable, and we have a string, and the dot new, which is an associated function available on the string. All these things we are still going to visit them as we go on. So basically what we did here is we were able to get the user's input from the terminal and then stored it in a variable, and we're able to print it. So the next thing we are going to be doing here now is the second phase of this um, game that we are building. And what we're going to be doing here is we're going to be generating a secret number. So in order for us to do this, we will be using a crate called rand. And so basically, what if you're coming from a JavaScript background, crates are like npm, where you have libraries that that contain code that you intend to use in your program, that can be executed in your program. And what rand does for us is it helps us to generate random values that we can use in our application. And how we do this in Rust is by adding the rand library in our cargo.toml. So you can open up the cargo.toml or toml, and here we say rand. We'll enter a version for it. So we want to use version 0.8.5. And in case you're wondering how I know all these things, um, there is documentation, and I've read about it, and I've also read like the Rust book and all that. So I'm not just performing magic and getting all these things from my head. So moving on, we've now imported the rand library. So we'll now be able to use this in our code to generate a random number. So now, how do we do this? So in order for us to generate a random number, the first thing we have to do is we have to import in our code. We have to import the rand itself. We have to import it into our code. So here we say use. So the way we do this, according to the documentation, we say use rand, and we import string RNG. I don't know if that's the correct way to pronounce it. We want to import this in our code and save. After that, we want to now generate a secret number. So we'll generate this secret number, and after doing that, um, we'll also test it by printing that secret number, a random secret number that will be automatically generated for us to the terminal. So the next thing we are going to do here is we are going to quickly go ahead and write the code for generating a random number. Then I'll come back and explain what it does. So what we want to do here is we want to generate a random number. So we've already imported the rand and the traits. So the RNG is a trait, um, that defines a method that the random number generator implements. If that makes any sense, but I know it makes sense as we go on. So here we want to say let's I'll call it random nums. So random nums will be equals to rand. And on rand we have thread itself, the thread RNG. So thread RNG, and on that place we now have the on this method we have random number generator. So it's called gen range. And so range, and there we now have the we have the range expression, where that takes from the starting to the end. So we are just going to quickly go ahead and run the program. So to do this, we'll do the cargo run. And we'll run this to build and we'll get some error message. And this is a nice thing. One of the things I love about Rust. So it's here it's telling us that no method named genRanger. Okay, so how it's supposed to be genRange found for struct thread RNG in the current scope. All right. So this error is coming from line 7. Tells us line 7, and we have to check. So in cases like this is where we want to go back to the documentation, because I've done this a couple of times. I know that this is gen range. So what I'll do is I'll go back here and I'll change this to gen range. And I'll do that. I'll run cargo run again. Cargo. Okay, I didn't save this time, so I'll save and come back again, clear, and I'll run this. You're getting that error. Okay. Okay, so apparently I found what was the cause of that error, and it has to do with my spelling here. So instead of Aru ENG I have to the correct spelling is Aru ANG. So that's why I'm still getting that bug and I was confused for a moment. So sorry, gen range. Yeah, gen range. That should be the correct spelling. And once again, I would quickly clear this and run once again. Okay, I didn't save this time. It's happening to me today. Yes. So on again, and yep. So now I have, secret number is 78, right? So it's still asking me to please enter a number. So I can still enter a number like, I just enter 7. The application still runs normal. So I still get to enter 7 and the application terminates at that point. Good progress so far. So the next thing we are going to be doing now is we are going to be comparing the value we entered with our, secretly or random generated number. So that's the point of everything. At the end of the day, we want to compare these both numbers or both values and see if they match. So if there is a match, we would, tell the winner if they won, or if the number is too big, or the number is too small, or something like that. So this would now take us to the next part, the third part of this mini game that we are trying to build up here, which is trying to compare the both values. So the first thing we want to do here is back once again, we want to go back to the good old standard library. And in the standard library, we have the CMP, which we use to the CMP. I think that is a trait or something. I'm not really sure, but I know that we have to bring in the standard CMP ordering into scope, which is available in the standard library. And what the ordering does for us is that it is, it's a type of enum that has three variants. It has the lesser, or the less, the greater, and the equal to. And these are like the three possible outcomes, that we can compare two values to. you know. So we have that. Then we have the CMP method that compares, the value. It does the comparing for us. Whenever we call anything on it. So basically, we want to compare the random number, which is this, with the value itself. So this value. So I'll quickly go ahead and import that into the scope of application, and I'll say, do this by saying use standard. In the standard, I want to get the compare, so CMP, and then I want to get our enum, which is called ordering. It is already suggested by my IntelliSense from VS Code, and yep. So here I'll add that. I'll save. Mhm. So I have this now in the scope of my application. The next thing I have to do now is to write out, the code that will enable me to do the comparing. And the first thing I want to do here is I want to use something called the match expression, which would still, like I've mentioned earlier on, would still be covering in later, you know, lectures where I'll talk about basics of Rust, like things that has to do with variables, mutability, data types, function, comments, control flow, the ownership system, structs, enums, and all that. So we'll cover all those things. But for now, in order for us to be able to, compare this, we'll use something called match. And what match does for us is, no, it compares stuff, and the match itself is an expression, that is made up of arms, and these arms, consist of patterns to match against, what we are trying to compare. So I'll just quickly go ahead and write the code, and later on, I would come back and explain everything that is happening in our code. So the first thing we want to do here is we want to say, um, let's say match. So we'll say ATCH to match, and we want to compare the value. So we want to compare our value. So on the value itself, we'll call the CMP. So that CMP, it's a method that will now take the reference to our random number. So reference to our random number. We'll say random number. Yep. And we'll hit enter. And remember, I said earlier on that our match has three arms. So this arms is going to be coming from the enums, the ordering enums. We're going to be comparing whatever value we're going to be comparing and giving out a particular number. So here we would say the first one would be the ordering. So we'll say ordering. So first of all, say ordering. I'm resisting the urge of using the IntelliSense, but it does help from time to time. So I'll start with ordering less. So I'll say less. If it's equals to, if it's less, if the numbers are, if one of the numbers is less than, so want to automatically print something. So we say print 29, and we would say um, our val nums numbers small. Yeah, too long, but explanatory. And we want to go with the second one, which is another ordering. This time around we'll handle for the greater than. So the greater, we say ordering. Say greater. um, say one number is too big. Yep. Use comma. So if you notice, you'd see I'm not using semicolon here. I'm using commas because that's the way you should do it when you're right, like the match expression itself. So now here's where we'll handle the equal, like the equality side of things. So we say ordering say equal, equal, equal. I want to also print line, say one, them, and I think that should be it. And yep, so save this and let's give it a go and see if everything works well. So hopefully everything should work well, but if there's any errors, we'll always come back to visit it. So now I'll go ahead and say, okay, I'm already getting an error there. I'll just leave it and run the code. I'll say cargo build, build, couldn't compile game due to previous errors. All right. Okay, random numbers. Expected a struct, expected a string, but found an integer. Okay. Okay, so the issue here is we see that we are having this thing, this error message here saying expected the string but found an integer. Arguments to these methods are incorrect. And so the core of this error is on this line that basically is telling us that we have a mismatched type. And it makes a lot of sense because in Rust we have something that is called type inference. And even if we pass a number or we passed a number in the terminal somewhere on this line, we passed in a number, it would automatically be inferred as a string because we are storing it in a string. In the simplest term, this is what is happening, and that is what is the cause of the error. So in the simplest form, we want to convert our string into an integer. And how we do this is by very simple line of code. So we'll just say let value, so the value itself, and then this value would say let value be equal to value for trim. So first of all, I want to trim for white spaces, make sure there are no white spaces. After trimming for white spaces, the next thing we want to do here is we want to pass it. So if it's a string, we want to pass it into an integer. So dot pass, and after that, we want to handle error. So expect here we say um, must be an integer. Yeah, so this line of code would help us to convert this value from being a string to becoming an integer, and hopefully will take away the error that we are currently facing. So if I save this and I'll quickly clear, I'll go run again. Yeah, so this time around I have another error. Now let me see what it says. Type annotation is needed. So okay, we're having issues with type annotation. Okay, so yeah, so we have to annotate the type. We have to explicitly say what type of value this is going to be. So we're going to call this a U32. Save. This should be fine. I'll clear and I'll run again. Exactly. So now the code runs. So my secret number is 99. If I go ahead and I put in something like 2, hit enter, I get our number is too small, which is the match here. And this line of code is running because obviously our number is too small. And if I run this code again, I go run, I get 52 this time. If I go ahead and say something like 99, I'll get our number is too big. I run this code again, I get 79. I go ahead and this time around I say 79. I'll get you've won the game, and it ends there. So at this point, we've completely, built out a functional game, but just some minor improvements to make, which we're also going to be touching as we go on. And those improvements has to do with the way the game ends abruptly. We're going to, we're going to stop that and do some um, you know, minor improvements, and include something that includes, allowing allowing the user to be able to guess multiple times, and be doing that using using the loop, basically. So in Rust, we have something called the loop keyword, and this loop keyword is going to enable us, to be able to, constantly, you know, um, guess numbers until maybe we use our hand to quit the game or to quit the program or something like that. And also, we also want to quit the program when we've won the game. And that in that situation, we're going to be using something called the the error keyword, the break keyword. So whenever we win the game, we know we've won the game and want to break out of it, basically. So what we'll do here is we want to wrap our code in a loop. So want to wrap our entire code in a loop. We'll wrap our entire code in a loop apart from our random generated number. So here I would say, um, okay, the first things first, we want to take away this log. So this was only added for testing purpose. So I want to take off this line of code. So take this out, because now we are sure that our program works. And then for the rest of the application, we want to wrap it in a loop. So we'll say loop, and then yep. And here I'll just copy everything here. I'll copy everything here, cut it, and I'll take it into the loop. I'll paste it there. I'll save, and then
Okay, so after wrapping everything in our code, we'll now go ahead and test the application or test our game. So we just start the application, start the game, we'll run it. And the first thing we'll see, we have, please enter a number. So I'll quickly save this and I'll cancel off. And I run this. Yeah, so now it asks me to enter a number after we've wrapped everything in our loop. So now I can go ahead and guess the number. So I'll just say, let me guess 12, hit enter, and it tells me our number is too small. Enter another number, if I enter something like 99, tells me that the number is too big. So for the purpose of testing, I'll quickly log um, the the random number, that is the value, so that we can see it and test together as so I'll be able to test all the use cases. So I'll just quickly paste this here. So basically, I'm printing the random number which is generated on this line to the console. So once again, I'll close this up and run the program again. And when I do this, okay, I didn't save. I'll save and run again. Yeah, so now the random number is 8. So I'll pick something lesser than 8. So 2, and determine that our number is too small. Once again, I'll close this, open it again. Or the right thing I should do is um, logging this or printing this outside of our loop. So yeah, so save this and I'll run it this time once again. So I'll go run and I have 39. And after that 39, it says please enter another number. So I'll enter something lesser than 39. So let me say 12, and it will tell me that our number is too small or is small. Please enter another number. And once again, I'll go ahead and say, let me enter something like 99. And it tells me that the number is too big. Now I have to pick a number lesser than, you know, the number equal to that. But the point here is the application runs without closing as we had in the previous implementations that we did. So the next thing we want to do now is we want to have this situation whereby when we've won, like when we guessed a number correctly, we want to automatically end the game, which I've spoken about before. So we'll do a couple of things and we'll achieve this using the break keyword. So this using the break keyword. And the simple way we are going to do this is on this last line. So the last line here, which is the third arm in our match, would do something a little bit different. So first off, we'll wrap this in curly braces, and this in curly braces. After wrapping it in curly braces, we add um, that's that. We wrap this entire part in wrap it in curly braces. So then we'll use a break keyword. We'll use our break keyword. Now we'll say colon, and here we want to use the break keyword. We'll just translate a break and to break. Whenever we've like picked a correct number, we want to break out of the program. So what we'll do here is we'll once again go ahead and so I would think the right place to log this would be inside this function. So add this here, print this here, save, and we'll start the program again. Run it. So we have 97. We're printing it in two places, so that's why we are seeing this number in two places. So we go ahead and we select 97 as the value. It automatically tell us that we won and to break off from the game, to break off from that process. But if we run the program again, and this time around we have 15, and I say, let's say we pick something like 19, which is a higher number, we get, please enter another number, which shows that, you know, it is like it's not like we've not won the game, it doesn't match the number that we currently picked. So the program still runs. And the same thing will happen for if we pick the lesser number. So this is how you um, you know set up you know a, a game. It's like a mini game in Rust. And basically what is happening here is the purpose of this very video is just to give a hands-on um, you know summary or experience of working with many features of the language itself. So basically, what I've tried to do here is render library, talking about converting a string to an integer, and using pattern matching, comparing, and comparing two values to check if they are equal, less than, or greater than, using the ordering, which is an enum, and so many other things that we touched on, which we are going to be looking you know, going diving deep into in the coming videos. We'll also be looking at things like reference. I spoke about reference earlier on, mutability. We're looking at mutability. We'll also be looking at basic things like variable data types function, control flows, structs, enums, and pattern matchings, and all that. So once again, thank you for joining me on this one, and I'll see you in the next one. Bye bye.